Thanks, everyone. I'm going to kind of round up today's series of presentations and just share with you a couple of transferable examples for nature-based solutions in Maine. So you might want to ask, why do we want to prioritize or focus on nature-based solutions? When I think of nature-based solutions, I think of everything from green infrastructure, rain gardens, to living shorelines. And what I'm going to be focusing on is a little bit more the living shoreline aspect and why might those be important. You already heard from Beverly about salt marshes and how they store carbon. They also trap sediment to keep up with sea level rise. They're very important for cleaning our water, providing vital fish habitat for biodiversity. They're also very effective at breaking up wave energy. And studies have shown that living shorelines have actually been more resilient to storm events than hard infrastructure. And our shorelines are being hardened at very, very high rates, including in Maine. So we want to kind of move away from those approaches if we can and use what we call nature-based solutions. Another good reason we should be thinking about this is our studies from the Maine Won't Wait report showed that about 43% of our protective dry beach, so that's what breaks up our wave energy, could be lost with relatively minimal amounts of sea level rise. And that's going to have an impact on not only our tourism dollars, but also, of course, vital habitat for threatened and endangered species. And it's our sand dunes that we have highly developed and provide that secondary buffer of protection from coastal storms. And our studies have shown that a lot of those sand dunes are going to be inundated, with that 1.5, 1.6 foot amount of sea level rise. And Beverly already covered on coastal marshes, but our marshes are very, very important also as storm buffers, but also for all the ecosystem services they provide. And they're seeing more frequent inundation. They're seeing conversion and erosion to different types of marsh species and increased stress for threatened species like the salt marsh sparrow that depend on them for a very narrow band of habitat. And finally, a huge percentage of our coastline is made up of erodible coastal bluffs, and about a third of those are actually eroding and being armored at very, very high rates. This image here shows you a bluff that is armored, and armoring of our bluffs can be done under our existing regulations, but it actually cuts off the supply of sediment to nearby mudflats and fringe wetlands, those things we're actually concerned about for carbon storage and buffering capacity and things like that. So our Maine Won't Wait report recognized the importance of nature-based solutions in several of the different strategies, strategy E, F, and G, as to why these are important and that we should actually be focusing on these types of solutions. So what I wanted to do is share with you three low-cost, transferable, and relatively easy to do examples of what I consider nature-based solutions or living shorelines. The first is going to be from Saco, Maine. We're going to look at dune restoration and enhancement. The second is hybridized living shoreline model for an eroding marsh edge. And the third is a hybridized living shoreline model for an eroding bluff. So if you've ever been to Saco and walked along what's termed Surf Street, this is an image from 2007. Right after the Patriots Day storm. This section of dune here has been eroding at a rate of about 2 to 3 feet for the past decade, several decades. So very, very high rates of erosion. And the typical response to that is to try to restore this frontal dune ridge. Okay, that's the traditional way of doing dune restoration. You try to hold the line by restoring this frontal dune ridge. Well, after the storm, we saw exactly what nature's trying to do, which is overwash that frontal dune ridge and put sand all in this back area here. So working with the Ferry Beach Park Association, we developed a kind of a unique design that said, you know what, we're going to build on the back side of this, not the front. So sand was trucked in and placed, and then it was planted with dune grass, and by the following December, it had done very, very well. And given the high rate of erosion at this location, this was unique because we didn't try to hold that line in the front, but realized if we build this in the back and allow this time to stabilize and for the plants to take hold, it's going to do that much better in terms of protecting the rest of Surf Street. So let's just take a look and see how that's done over the years. 2015, 2019, and 2020 is the last photo I have from this area. So in an area of very, very high erosion rate, it's still performed quite well in terms of holding back overwash and also allowing this to be a natural buffer for storms. You can read about this in a document that was prepared by the Nature Conservancy. This is one of the featured case studies for a living shoreline approach. And it cost about $29,000 and was built basically by volunteers, aside from the city that trucked in the sand that was used to develop the dune. Next, I want to share with you some highlights from a NOAA-funded project that we've undertaken with a variety of different partners. This is going to focus on these more hybrid living shoreline approaches in Brunswick and Yarmouth. As part of this project, we asked ourselves, how can we beneficially reuse naturally occurring materials? And we saw lots of tree trunks on the beach or on the side of bluffs that need to be cut, and lots of oyster shell. There's an oyster shell recycling program in Portland now that's underway. So we wanted to beneficially reuse these as best possible. So these are the two project sites. The first is in McCoy Bay Conservation Lands, which is an undeveloped land in this area of McCoy Bay in Brunswick. And the second is on Lanes Island. It's owned by Maine Coast Heritage Trust and is about 500 feet of eroding bluff. And our project sites are small demonstration treatments that are about 50 feet in length. So this is looking at McCoy Bay Conservation Lands. It's your typical eroding marsh edge. You can see these slump blocks. You can see the mud flat out in front of here. And each year, this erodes back farther and farther, and ice chews this up. But one of the challenges that we encountered through this was the traditional way of using oyster shells to bag it in this plastic clam netting, and then it just literally falls apart and floats away. So it degrades in the environment. And we didn't want to introduce additional biodegradable plastics or degradable plastics into the environment. We also had the challenge of ice. A lot of the living shorelines that are designed don't need to account for ice. This is what the typical winter looks like in McCoy Bay Conservation Lands. So we needed to break up this ice. So our solutions were to test two different products. One is developing this brand new coconut fiber weave coir bag that if it gets filled with oyster shells, they're about 12 by 24 inches. About 30 pounds they weigh each, and volunteers can easily place these. And the other was to test a brand new product called a GeoReef. And it's basically a gabion plastic UV and heavy resistant synthetic product that you fill with oyster shell. So very easy to put into place and then fill with oyster shell. And it's guaranteed to not break down. So we wanted to test these products. But we also wanted to integrate trees. So this is our 50-foot design for the demonstration treatment that was developed by GEI Consultants. You can see our gabion baskets or GeoReef over here, and our shell-filled bags on this side over here. And we integrated trees in this by using what we call tree runners. These are perpendicular to the shoreline and meant to break up wave energy and also ice when it approaches. So this is what it looks like putting those trees in. This was all done by volunteers. Filling the crevices with bags and the gabion baskets, then filling them with shell and staking everything into place. We built this in 2 days. This is what it looked like after we were done. You can see the oyster shell in the gabion baskets, and then the bags that are filled with oyster shell. And this is what it looks like from last month. You can see there's some settling that's occurred. I've had to replace 3 or 4 bags, but in general, it's performed pretty well. The next site is a much different site. It's a very dynamic, highly eroding bluff along Lanes Island. This is about a 10 to 12 foot bluff. The idea here was to again use a 50-foot demonstration treatment that beneficially reused all these fallen trees that you can see in this image and built what we call a stepped crib, basically. This is, again, about a 500-foot eroding shoreline. So the design was to build these tiers or these steps by beneficially reusing those fallen trees, put root wads and sand into the toe, put additional sand out in front of this so it would be sacrificial to the beach, and then use root wads on the ends to try to combat end effect. So this is the existing cross section of the shoreline. You can see the steep bluff. That was regraded back and to a more stable position, and then these different steps would be put in place and then filled with that excess material, planted with native vegetation that becomes less salt tolerant as you go up the slope, and then excess material was placed here. And what's unique about this design is if the first step fails, all that material is released to the beach system. Okay, so very unique and very different from your traditional riprap structure, which is not supposed to fail. This is what it looked like during construction. The fallen trees were taken, and Sumco was the contractor that did this. And they built this through this entire area, and then placed the trees, and then planted it with different kinds of salt-tolerant vegetation, placed the excess sediment, and in the following month, this is what it looks like. We already lost a little bit of that sediment, and unfortunately, by January, we lost the first step of the installation here, but you can see it actually is releasing sediment into the intertidal zone. The erosion rate at this place has been so bad that it has actually outflanked the installation. So maybe this wasn't the best place to site this, but we think this type of technique is certainly transferable to other coastal bluffs. And if you'd like to find more information on these, here are some links. And I'm sure this presentation will be posted, so you don't have to jot these down very quickly. Thank you very much. That's all I have for you.